there are a few things about the periodic table that you'll be given both by me and on the AP test that I suggest that you understand and that you mark on your periodic table. The first thing is I want you to notice that I have marked some numbers going down. These are periods. And so if you notice over here that you see that I have written over here 1, 2, 3, 4, 5, 6, 7 going down. These represent the periods. For example, hydrogen and helium are both in period 1, and lithium through neon. If you look at lithium through neon, that's period 2. And what the periods tell us is really how many energy levels each of these elements contain. Also, notice that across the top, these are your group numbers I have written going across horizontally, although they represent the vertical column. So hydrogen through francium are in group 1, beryllium through radium is in group 2. I always get those two confused, and so on. So it's a good idea to go ahead and number your periodic table with these period numbers and the group numbers. Also, notice that I have added in this really bolded blue line. This line is very important. It separates everything on the left side of this line, and very important to understand left means something, that these are the metals. And what we're going to find is that metals lose their electrons. So notice left are losers. Now there is one exception to this, and that's hydrogen. Hydrogen is not a metal. Hydrogen is actually a nonmetal, where the nonmetals typically are on the right side of this blue line. So very important that you have marked this blue line bolded on your periodic table. Now also notice that this periodic table does not have the written words of the elements, and so you really need to spend some time memorizing the elements that you do not know. Now you're not going to spend a lot of time at the bottom with the lanthanide and actinide series, and there are several of the elements, throughout, especially the ones near the bottom, that you won't really be dealing with. But I would say to have a really good understanding of at the first 40, and then there are some ones in the middle that are very important. Silver and gold and lead, some of the strange ones that you need to make sure that you know. They do sometimes use antimony, so it's very important you know the symbols or you're going to be way behind. Also, the group numbers can correspond to actually group names. They've named 4 of them. Notice that the alkali metals is group 1, except hydrogen's not a metal, so hydrogen is not an alkali metal. So lithium through francium are the alkali metals. Group 2 has a name. It's the alkaline earth metals. These two groups actually are what's going to be the key component in a base, and a base are called alkali or alkaline. And then the other name, they don't name group 13, which is the boron family, but there's not a specific name for it. Carbon family, nitrogen family, oxygen family. They did call that the chalcogens at one time, but it hasn't been widespreadly used. But then group 17 are the halogens, and group 18 are the noble gases. So you do need to know those 4 column names. Very, very important. Okay, next on this periodic table, it's important to be able to identify the oxidation numbers. An oxidation number is the result once an element has lost or gained an electron. And so remember what we said about everything on the left. They were metals, and they are the losers. And so they're going to lose electrons. So what you need to remember is that when you lose an electron, it becomes positive. Why does it become positive? Because your electrons and protons start off even. So for example, lithium here. Lithium starts off with 3 electrons, which have a negative charge, and 3 protons. Well, the protons are not going to change. Those identify the atom. So the electrons are what's going to move around, and really all of chemistry, pretty much, except when we talk about nuclear chemistry, is about what that electron is doing. So if an electron is lost, then it becomes 2 electrons. So if we minus 1 electron, Then we have 2 electrons, but we still have 3 positives down here. So what's the result? Well, we have an overall charge now of +1. So everything in the first column is a +1. Well, those +1s and +2s, or anything that has a plus ion, is called a cation. Cat, C-A-T, cat ion. Well, think about a cat. It has paws, so they're positive. Also, notice the T in cat, and that should help you. A T looks like a positive sign. Now, everything in group 2 is +2 because it's going to lose 2 electrons. And so again, beryllium starts off with 4 electrons, 4 protons, loses 2 electrons, so now it has 2 extra, 2 over the number of electrons in its protons, so it's +2. If we continue on, we're going to come back to these. The transition elements act a little strange. So if we look at group 13, notice group 13 is going to be a +3. And notice 3. That's how many valence electrons there are. So it's going to want to lose those valence electrons. 1 valence, 2 valence, 3 valence electrons. Valence means outer shell. Group 14 has 4 valence electrons. Well, group 14 is kind of interesting in that it can either lose its 4 electrons. Its goal, again, is to kind of be more stable and look like the noble gases. And so it's going to either lose 4, and it could look like helium, or it can gain 4 and look like neon. So what's it going to do? Plus or minus 4. The deal is, though, that normally carbon and silicon will not ionically bond, and that's really what we're talking about. Oxidation numbers deal with ionically bonded compounds, but they're usually going to covalently bond. They're going to share. They'll do whatever they can to get an extra 4, so they'll share with each other. Now, nitrogen, phosphorus, and arsenic are going to be, well, if you look at 15, this has 5 valence. It would love to have enough valence electrons so that it's going to look like neon, so it needs to gain 1, 2, 3 more. And so if it gains 3 more, it becomes a -3. Well, why minus? Now your electrons have added. Your protons are still, like for nitrogen, still 7. Your electrons start out at 7, but you gain 3 more. So if you gain 3 more, you have 3 over your number of protons, so a -3. Notice 5 plus 3 is 8, also kind of helpful. So then group 16 has 6 valence. It's going to want to gain 2 more to get that 8, that octet rule. And so everything in that group pretty much will be a -2 charge. And then 1, 7 plus 1 is 8. And so we get a -1 charge. And then if you look, this has 8 valence electrons except for helium, obviously. It only has 2. And so it will not gain any. Now, I kind of skipped some stuff over here. And there's a reason for that, that this actually has a valence of question mark, positive question mark. Well, what's the deal? Why positive question mark? Well, these can have multiple oxidation states. In other words, iron can actually lose 2 electrons, or it can lose 3 electrons. It depends on who it's bonding with. And so same thing for nickel and for copper. And so because they can have multiple oxidation states, pretty much anybody who is from this line all the way to the stair step, yes, even things that are in group 13 and 14 and 15 and 16 can have these multiple oxidation states. Now there are a few tiny little exceptions in that aluminum does not. He is always a +3. Zinc is always a +2. And silver is always a +1 when it bonds. And cadmium we'll also see as a +2. So these guys don't have this positive question mark. They have set oxidation numbers. Now again, let's talk about carbon and silicon. We said are plus or minus 4, but what about germanium, tin, and lead? Well, they have a positive question mark. So yes, they can be +4, but they can also be +2. So it just kind of depends on who they're bonding with. Well, how do we know? How do we know what their oxidation number is going to be? Well, in the name, we're going to be given a Roman numeral. So I call this the Roman numeral section of the periodic table. So you'll be given a Roman numeral. For example, if you're given a compound and it's copper Roman numeral 2, that Roman numeral 2 is telling you that copper is plus 2. Also, you can figure out what the oxidation state is by determining how many of these guys they're bonding with. And so you can tell by the balanced out what the oxidation number is. And we'll do a little bit of that later. So again, oxidation numbers are these numbers that I've written on top. They can also be determined by the compound, and we'll do that a little bit later when we get into redox. And then ionic bonding is that transfer. So for example, lithium is going to give one electron away. And so who gets it? Well, that would probably be great if one of these guys who need an electron will pick it up. So lithium may react with fluorine and so make lithium fluoride, just LiF. Or it may have to have two lithiums to give away two electrons to an oxygen. And so that's ionic bonding, and that's really where we're going first.